How's it going, everybody? Welcome back to our NSX-T series where we're going to be diving into getting the basics of NSX-T operational. So up to this point, we've gone and deployed NSX Manager, we've got the transport nodes added, we've got the NVDSs created, all that good stuff. And then I covered some of the theoretical pieces to NSX, so you guys should be on a pretty good understanding of what the capabilities are. Now it's time to actually put the rubber to the road and actually go somewhere. So what we're going to be doing in this video is I'm going to be walking you through how to create a segment and deploy it and then move VMs to a segment. So this little section here is going to be kind of quick because there's really not a whole lot to it. So actually I'm going to go to the next tab, and what we're going to be doing is this. I am going to take the connectivity that's right here. See this dotted line? This dashed line right here is going to be the connectivity that we're going to be setting up in order for connectivity to go out to the outside world via a NSX port group. So it covers the entire length of the deployment, right? So we have these dotted dashed lines that are connecting us to the outside world. Now, the intention of the red lines also are going to be showing that those connections will be going out to the CSR 1000Vs. The blue line attached to the two different VDS port groups are indicative of the communication path that they're going to take for any VMs that are attached to the existing VDS port groups. Where when we go to do the NSX port groups and deploy those segments, that traffic flow will come in the VM VNICs will get mapped to the segment, and then that traffic will follow the red path to their default gateway. So we're going to be able to get the communication up and running between both VDS port groups and NSX port groups using the NSX VLAN back segment that we're going to be deploying here in just a moment. So that's basically what we're going to do, and that just shows the data path that's going to be happening and how it's going to connect to the CSR 1000V. So now that I've talked about that, let's go ahead and this is layer 2 only. So I'm only providing layer 2 connectivity between the VMs that are on the host that have a VNIC in the NSX port group or in the NSX segment, and then the connectivity to the upstream router. So what I'm going to go do is I've gone through and I've created 4 more Linux VMs. So that means at this total here, I have a total of 6 virtual machines. And I'm going to click the little thing here, show hide columns, and I'm going to go to host because I wanted to show which host these boxes are. So I've got a mixed bag. I've got 2 on host 2, 2 on host 3, and 2 on host 1. So I have a even distribution of communication. So now what I'm going to go do is I'm going to click on NSX. I'm going to come over here to networking. I'm going to go to segments. But if I click on network topology, just to see what that looks like, there's nothing here because we haven't found any objects or entities that have been created yet. So I'm going to go to segments, and I can click on, I have segments, I have segment profiles. Here's all the segment profiles I was talking about before. If I want to add a segment profile, here are the capabilities that I have available to me. If I want to do layer 2 bridging, this is where I would do that, create a bridge profile. And if I wanted to create a metadata proxy to download stuff from a API server, this is where you would do it. So I'm going to go back over here to segments. I'm going to click on add segment, and it's going to say what's the segment name. I'm going to say NSX. It's going to be Linux VLAN 100. Connected gateway. I don't have any tier 0 or tier 1 gateways deployed yet, so therefore I'm not going to be applying one. The transport zone is the important part. So even though this says it has a red asterisk next to it, that's actually not that important. I'm going to click right here. I'm going to say VLAN TZ for the VLAN transport zone. I'm not going to give us a subnet or a gateway. This is if you were going to give it an IP address, this would be for your overlay segments, and you would give it an IP address, and that IP address would be pushed down to the transport nodes that are hosting any of the VMs attached to that segment. Down here in the VLAN, I need to specify 100. Click away, and there we go. There's a bunch of other options and stuff like that. I'm not going to be diving into those right now. I'm just going to go ahead and click save, because that's the minimum requirements that you need to have. Name it, attach it to a transport zone, the VLAN TZ in this case, and then define the VLAN ID. It says the NSX Linux VLAN 100 was created successfully. Want to continue configuring the segment? No. So now it's been done. I'm going to come over here, and I'm going to go to the networking tab, and you can see right here that this has been created. And it's not obvious, but you can tell the icon looks different between this guy here and this guy here. There's a slight differentiation between the two. So there's 4 hosts attached to this specific port group, but no virtual machines. So here's what I'm going to go do. I'm going to go ahead and move a VM to it. So I'm going to go ahead and click on Linux 1. And this is how you would make this migration. I'm going to go ahead and bring this down just a little bit so that it's easier for you guys to see. I'm going to go to Actions, Edit Settings, and then here in the network adapter, I'm going to click the drop down and go to Browse. And then I'm going to come down here to NSX Linux VLAN 100 and click on OK. And then I'm going to click on OK again. And then you're going to see the reconfiguration of the virtual machine. So now my network changed to that. However, if I was to pull up this VM and go to, let me go launch the remote console. Give that a couple seconds here. You can see I prefer this methodology versus any other ones. Type in the password. Go ahead and let that log in. And once we do, we'll be able to talk to the rest of the network. Now if you press Control-Alt, you'll be able to break out of that and move it around. Click back inside of it. It's going to take a couple seconds for that to do its thing. Okay, well it took a couple minutes for it to finally get to where I wanted it to be. So I'm going to just right click here and go to Open Terminal. And I'm going to do an ifconfig. I've got an IP address of 172.168.100.14, and I'm going to go ahead and ping 172.31.100.254. That's my default gateway, and that responds. I don't know if ARP-A will work here. That's a Windows. It does. Okay, cool. So we can see that I've got, this is the HSRP MAC address. This is my HSRP VIP, and I can ping both .1 and .2 accordingly. Now, if I was to go to Linux 2 and do the same thing, let's go to Linux 2, launch remote console. We should be able to ping back and forth. Go ahead and pull this guy up too, just so we can go back and forth. Even though it says Linux 1, I haven't changed the host name. It's the tag is different, but because this is a clone of Linux 1, it's going to continue to show up that way. Not that big of a deal though. I could probably very easily change the name. I'm just lazy. Not that important. So I can ping my gateway. Now again, this is now attached to a VLAN back segment. So if I was to come in here and click on refresh, I have one port right here. Click on this guy, and it's to tell me Linux 1.vmx, and this is the segment port name. So if I was to say view more, this is what it's giving me. And the address binding, there's nothing here. There's no application interface. There's no segment port profiles attached, except for the default ones. So, and that's the port ID that it's got. So So we're connected to this segment on this specific port. It gives you some long UUID. But if I go back over here to this guy and I click on, he's taking a minute. So what I'm going to do is I can actually cheat a little bit and look right here. I can see what the IP address is. It's .15. So I can come in here and do a ping to 172.31.100.15, and that should respond, and it does. It responds, so I know I have communication between the two VMs. Now, what's interesting about it is I have connectivity to this guy, but he currently sits on DC1 Compute Linux. So Linux 1 here and Linux 2 are in the same VLAN. However, they are not attached to the same port group. So if I do ifconfig, we are 100.15. If I was to ping 172.31.100.14, I can ping Linux 1, and I can do an arp-a, and I can see that coming through. If I come over here and do an arp-a, I should see 15 show up in my connectivity. So I know I have bidirectional communication, and that's exactly what I want to see. So now that I've got that under control, my flow from point A to point B is my traffic for well, let's go for the VLAN back segment to VDS port group. My traffic sits right here. Actually, let me go ahead and pull up my drawing software. I haven't been using that in the series yet. Go ahead and go to yellow green and make it big. So if I'm sitting here, I've got a VM attached to this guy right here. His traffic is flowing out here, right? And what's interesting about it is as soon as you hit the physical network, you're able to get switched. And you're switching right here. So you're off the NSX segment once you reach this, and then but the NVDS and the compute VDS are not attached to each other. So you actually have to go north stream. So think of this. Go ahead and clear the screen real quick. Think of this lab vSwitch as the upstream top of rack device. That's how you need to correlate this. So I have traffic coming in from, oops, that's not what I wanted. How did that happen? Yellow, green, medium. There we go. That's weird. Oh. So I have traffic going out here, gets to this switch, and then it goes back in to here. And I have bidirectional communication. I can ping back and forth. MAC addresses have been learned. And that is VLAN-backed segments. So now what I get to go do is this. You go ahead and minimize this. Actually, let me click back on that. Click back on the mouse, minimize this. Let me go ahead and get out of the way. Let me clear the screen real quick while I'm at it. Clear this. Let me minimize this. Now let me go over to NSX, and let me show you guys how something works. Let me click outside of here. Click over here. Close this guy out. Now I'm going to go over here to security. I'm going to go to distributed firewall. Inside the distributed firewall, I'm going to have applications. Now there's a default layer 3 section right here that is going to, if we hit the arrow, we have a neighbor discovery protocol for IPv6 traffic. We have a default rule for DHCP for both server and client, so that if you have an external DHCP server, you'll be able to send traffic back and forth. And if you have a layer 3 rule, you'll be able to allow traffic. So right now, the way that this is working, there is 3 rules for IPv6 neighbor discovery, IPv4 DHCP, which essentially is doing the same thing at NDP, and default layer 3 rule is saying basically permit IP any. That's an any rule and applies to everywhere. If I was to go in and create another rule and say deny ICMP from one VM to another, that would allow, I'm going to say from the VLAN back segment outbound to the VDS port group. Let me go ahead and show you guys what that would look like. I'm going to add a new policy. The policy is going to be block ping, and then I'm going to go expand this out. Say add rule, and the rule is going to be, this will be NVDS to VDS PG, and I'm going to say the source, hit this guy right here, and we need to say what is it that we're going to be adding in. So add a group. We're going to say VM set members. We have the criteria virtual machine equals, and we're going to say virtual machine name Linux 1. Gonna apply that, save. That's successful. Apply. That's going to be for Linux 1, and Linux 1 currently is attached to, give it a second to pull up, is applied to the NSX port group. So what I'm going to go do is I'm going to, it's block, we want it to block ping. So what I need to come in here is the destination is going to be any. I'll just put in destination as any for right now, but the service is what I need to block. I'm going to click here in the service, and over here on the right hand side I'm going to type in ICMP. Hit the enter key. We're going to get we're going to say echo request. We're going to drop it. Click on apply, and then we're going to come down to here and we're going to say drop, and then we're going to go ahead and publish. It's going to block ping. So that'll take a couple seconds for it to push, and now it's going to push to every host. So regardless of where a host sits on any of these guys, it's going to affect Linux 1. So this is going to be a source-based rule. See if it's done. There it goes. So now it's been successfully deployed. I'm going to pull these guys up again. Here's Linux 1. Here's Linux 2. If I go up here and I tried to ping, whoops. If I tried to ping 15, I'm not able to ping. Right? I can't ping outbound. Now if I come over here to Linux 2 and type in the password, I should be able to ping. Let me go ahead and ping 14. And you're like, well, how come that worked the way that it did? So let me just clarify why things are happening the way they are. Let me go ahead and cancel this ping. So it was 100% packet loss. Now, the reason why Linux 1 was not able to send pings out, but Linux 1 was able to respond to pings from Linux 2 is because in the firewall rule, I said echo request, not echo reply. If I was to go in here and change up the services to be, say, ICMP all, so if I was to close this guy out and say ICMP, or actually I should say right here, clear that off, and say ICMP all right here, and changes it up, and then I was to go to publish that. Let me go ahead and get out of the way. It's going to take a couple seconds for that to push. Give that another. There it goes. Let me go back over here and back over here. Hit the up arrow. Ping it again. The ping is not working come over here and ping this. Okay, so it's working. Okay, you know what, that makes sense. Because this is inbound. So, but in this case here, I can't ping outbound. Technically speaking, I shouldn't be able to ping revert back, but that's okay. I'm not terribly worried about trying to do bidirectional traffic, but I did want to show you guys what that would look like. So, but now we've got it set up the way that we do. I'm going to go ahead and I'm literally just going to come up here and I'm going to say delete. Delete that rule, publish, and after a couple seconds, you're going to see that this will go away. I'm going to go ahead and refresh that. There, it's gone now. Bring these guys back up and bring him back up. There. The ping is working again. So, because the firewall rule is no longer there. So, that, ladies and gentlemen, is how you could leverage the firewall to do what we want it to do. And that's just a basic ping test. And that is, like right now, I'd say probably 60% of the projects that I work on, this is the reason why folks like NSX-T, because I can go down to the vSwitch level and do firewall rules. So, pretty powerful stuff. And that was just a basic test, right? We're going to be going into more complicated firewall policies and stuff like that. But I like doing a basic demonstration like this because then it proves out the capabilities. So, with that being said, ladies and gentlemen, that is it for this video. I'm going to go ahead and show you guys how to do some more stuff when it comes to overlay segments in the next video and how that'll all come into play. Until next time, guys, thanks so much for stopping by, and I'll catch all of you in the following video.